In number 28, we have a 1200 Newton uniform boom supported by a cable perpendicular to the boom, as shown. The boom is hinged at the bottom and a 2000 Newton weight hangs from its top. Find the tension in the supporting cable and the components of the reaction force exerted by the boom by the hinge. So this is kind of interesting. So we've got the tension here. We also have, you can think about the center of mass of the beam acting down this way, so that's 1200 newtons. And then the angles here, and you can work this out very quickly. These two angles here both are going to be 25 degrees. And you might say, wait a second, how do you know that? Well, if you extended this line down, which I'll put down here for a moment, this forms a right triangle. And this other angle up here to the 65 degrees has to be the complementary angle, 25. So the sum of those would be 90. And now the question is, all right, what is that force in that supporting piece right here? Well, we can use torque counterclockwise equals torque clockwise. And in this case, the only counterclockwise torque is going to be the tension in this rope over here. If you think about, again, this as being your pivot point right down here. And our two clockwise torques are going to be the force of gravity on the beam itself, or the boom, and this hanging mass. So plugging in our numbers, the tension here is being applied at 3/4 of the length. So that's my distance here. The tension is the force, times the sine of 90. This is 90 degrees if you work it out. Equals the 1200 Newton force, which is this one due to the center of mass. And of course, it would be half of the length of the rod. It should be right in its middle, times the sine of 25. And then finally, the 2000 Newton weight, which is at the very end, times the sine of 25. Now, first thing I can do, I can very quickly remove L because all three terms have L in it. And then I'm going to go ahead and multiply 1200 times the sine of 25 and 2000 times the sine of 25, which gives us this. Kind of nice, not too hard to solve. And then if you solve this, you'll discover the tension is 1470. That's the first part of the question. And then the question is, what about the components? Well, before we can do that, we probably should break the tension into its vertical and horizontal components. So we know the tension is 1470. Breaking that into its vertical and horizontal components, just using sine and cosine of 25, we get those. So what does that mean? Well, the only other point where there's force being applied is this bottom piece right here, that bottom hinge. And the question is, what are the forces it must exert? Remember, this system's in equilibrium, which means the sum of the forces must be zero. We've got 1300 acting horizontally this way. So that means down here, we've got to have 1330 acting the other way. So the net horizontal force is zero. And you might say, oh, this is easy then. The other force here has to be 1290 downward. Well, please remember, vertically, we've got this force, we've got this force, and we've got the 1200, which I don't have listed here. If you work it out, the total downward force is 3200 newtons, the combined weights of the boom and the hanging mass. And we've got the 619 upward force due to this. All the remainder must be due to this component down here. And if you do your subtraction, you'll discover this one has to be about 2580. So those would be the two components of force. And yes, you could find the resultant of these and figure out it's pointing somewhere right around here at the hinge. I hope this helps.